I'm Dr. Eric Schultz. I'm a radiologist. I don't know how much information you have about me. I trained at UC San Francisco for MD, PhD, so I'm a bit of a glutton for punishment. And then I did my residency at Harvard's Mass General Hospital. And then found myself, after a few years, in, I guess what is called medical desert in the Philippines. I got there by way of doing teleradiology, doing night call for cases in the US, which 12 hours time frame difference is daytime in the Philippines. So that means that I don't have to be a vampire when I'm reading my cases. One of the things that became pretty obvious as I was doing my teleradiology was that there was a really huge shortage of radiologists in emerging markets. And so when I sold that company, I kind of looked around and I said, what should I do? And I sort of hit upon this problem. And I think, first off, I'm super happy about being invited here. And I was very impressed with the idea of reverse innovation, because I'd never heard that term before, but it's very apropos with what we're doing, because we have a shortage of radiologists. It turns out, I thought it was one amount, and then as I was developing this talk, a colleague of mine in the United States sent me an article that mentioned that 2/3 of the world's population has a lack of access to basic diagnostic imaging, 2/3 of the world. And so I thought, well, and this was just recently, but I've been working on this for 5 years, and I guess next slide. Or do I press the button? Okay. So first off, what is behind that 2/3, right? How do you get to a number like that? 2/3 of the entire world's population doesn't have access to basic diagnostic imaging. And so that's a pretty huge number. Well, in the USA, if you look at just number of radiologists per capita, per 100,000 patients, there's 8.5 radiologists. I'm in the Philippines, where there's 1 radiologist per 100,000 people, but it drops off even after that to like Vietnam, where you have 0.8. And then if you go to Africa, where we have installations now, it's far less. And so that's an incredible number, because while not all health problems are diagnosable by radiology, the ones that are, it can be such a critical issue. So one of the problems is that there's just a raw number issue. There's just not enough radiologists. The second number is distribution. So I follow kind of the 80-20 number for most of these things. And so in the Philippines, there's 100 million people. It's a nice round number. 20 million people live in Manila, which is the capital and the biggest metro. And you've got something like 70 to 80% of the radiologists are in the metro. So you've got 80% of the radiologists taking care of 20% of the people. And the converse is that you've got 20% of the radiologists taking care of 80% of the people. Okay, so that's another issue. And then the third issue is productivity. So the radiologists that we see, they're actually more like consultants in the sense of they're independent consultants. So they may do 2 hours in the morning at a small clinic, and then drive through that kind of traffic for 2 hours to go 8 kilometers, and do 2 hours in the afternoon, and then drive out to a province to do another 2 hours at a hospital. And so that's how you get this number like 2/3, and I think it's actually far worse in some cases. So how do you tackle a problem of resource scarcity? And this gets to this innovation side of things. Well, one thing you can do is to make better use of the resources that you have. So you have a certain number of radiologists. Right now, it's almost like a large part of the world is using stone knives and bearskins. And by that, I don't just mean film and typing the reports. I'm talking about all of the software that was written in the 90s and early 2000s, and the toolkits from those era are still the basis for all of the radiology diagnostic software that we currently use. And so the problem with that is that these software is very inefficient. It's so there's an issue of how do you make them faster? Well, one is by using better technology. There's this funny thing called the internet that came up in the last 20 years, and then you can leverage a marketplace. The other thing you can do, and this is something that's almost never done by commercial operations, companies, is to create more of the resource. And so our software, the Lifetrack Medical Systems software, does that, and I think this is the key thing. So in terms of improving resource utilization, one thing is by improving productivity. So we actually have a US patent on a sort of structured report, or you could think of it as a checklist of how you do a radiology report. But the cool thing about it is that as you're going through it, it gives decision support that helps the radiologists if they don't know how to characterize that specific finding. The second thing we do is we leverage other companies like Amazon. So, Amazon uses FedEx to deliver packages. We use Amazon to deliver data. And so the idea is that we want to move the data, not the doctors. So it's much more efficient if you have a doctor who has 8 hours of work time in their day. They're not spending half of it on the road. They're spending all 8 hours in front of the computer reading cases. And then this kind of technology also allows people to do diagnosis from a distance so that you can have a marketplace where you have flagship hospitals in the big major metros and you have small provincial hospitals who can take advantage of that. Creating more of the resources, the other side of the equation, and I think there are a lot of doctors in the audience. I don't think I'm wrong in saying that medicine is one of the most archaic and fields of human endeavor. And there's a reason for that. The Hippocratic Oath is first do no harm. So the last thing you want to do is change something and then find out that it did harm. So, but at the same time, you have to make improvements if you're going to change the way that medicine is done. And if you look at this slide, this is 2,500 years ago. This is the way we still train our doctors. It's guild, master, apprentice. Hippocrates was master of the art of healthcare at the time, and there's his apprentice. The big difference is that they were wearing robes back then, and now we wear white coats. So there's a lot more that we can do. And this is where the idea of reverse innovation comes about. Because I saw this issue of how do we train radiologists at scale, without doing sort of what the usual is you do a helicopter model of bringing in some radiologists from a high-end institution, you put them into one of these medical deserts, and then you hope that something changes, whereas when they leave, things kind of regress to the mean. So I sort of took some of my experience from doing the teleradiology, and I said, well, what if we actually extend the reach of the knowledge base? And so that then we're actually extending the reach of subject matter experts from places like Mass General and UCLA and UCSF and bring this information to the radiologist at the time and point of contact. So this is, actually I have a video. I don't know if that is doable. Did the video next? No, huh? Oh my, okay. Is there an option to play the video still or no? Maybe not. Well, I have a video that shows how it works. Maybe if I go back, I can kind of show you a little bit. So the video would actually show you how, when you're looking at something like a brain hemorrhage that you'll see up there, when you go through the actual report, that's a structured report, when you get to the line about brain hemorrhage, you can actually click on context-sensitive help, decision support right there in the box, and it will actually bring up what you see sort of, I don't know if this is going to work. No. Was that? No, I thought it had a, no, okay. Well, the far left-hand side, the left-hand side of the screen is the decision support. And so if you were looking at a subdural hemorrhage and you saw the different types of hemorrhage, 4 different types of hemorrhage, if you drag the image into that mimics or that looks the same as the image that you're looking at, you drag that into the text, it will actually bring in subject matter experts' best practices description of how do you actually address a subdural hemorrhage. And so then it's giving you constant reinforcement on top of giving you on what the best way to handle a subdural hemorrhage is. It also is giving you constant reinforcement to look at all the other types of hemorrhage. So what we found actually is that it's enormously successful in getting people to do a good job at doing their reports. So what this means in terms of, this kind of an audience is that we can actually train radiologists in emerging markets and do scalable social impact by actually doing capacity building inside the country. And so we're actually working with different academic hospitals around the world, and we're actually having them build the part of these knowledge base and decision support in order to help radiologists around the world and actually build more radiologists so that we can use that to help scale radiologists. The other thing that we're able to do with our software is that we built it so that it runs entirely in the browser. So that doesn't mean cloud. So I don't like the word cloud. What it is that the software runs in the browser, so there's no install. It runs on Macintosh, it runs on Linux, so that you don't even have to pay for the Windows license, and it'll run on Android. And the idea is that if you're going to be going into the rest of the world, you need to make it simple to use the software, and you also have to be able to make it scalable. So in our software, we can have on-site, off-site, and hybrid. So that way, and it was designed with the parameter in mind of being able to do Department of Health or Ministry of Health level deployments, 100, 200, 500 hospitals. And everyone can be being read on-site, off-site, or any combination thereof. So it's actually architected to handle MOH level and DOH level deployments. You can have radiologists in, for instance, we have a memorandum of understanding with GE where they will install CT scanners or MRI in places like Nigeria with the software, and because sometimes there's no radiologist to read there, they can actually take advantage of other users of our system who are teleradiology providers, massive scale teleradiology providers in India to do the reads there. So it doesn't even have to be within country, it can be outside of the country. But the real goal is to use that to help train inside the country so that you scale internally. It also allows radiologists in the metros to read for patients in the provinces, and same thing with specialists. And overall, it decreases costs. So here's our current customer base. I think we just added another country, but so obviously Philippines is our own backyard, but we've got commercial installations in Indonesia, a bunch in India, same in the US, just started Vietnam, Singapore, Nigeria, Bangladesh, Pakistan, and Brazil. And we actually have, this is unheard of in the radiology, what's called FAMx system, which is picture archiving and communication system. Unheard of is that both GE and Philips, recognizing how unique our software is in being able to scale, and also to be able to scale in countries, in developed, emerging market countries. They've actually signed MOUs with us to actually sell our software with their devices. This is our first academic partner, and we've got a few more that we're under discussion with. They're at Bern, Switzerland, and we're very happy to have them on board. And so I know that one of the things that we were asked to do was to address how can this audience help out? Well, we're looking for academic radiology programs that really want to help expand the reach of, the ministers of health all throughout Southeast Asia, and it's probably true for the rest of the world. They want to extend the reach of high quality medicine. That's the mission statement. And so it's very hard to do that if you don't have it. And so one of the ways to get it is to basically build more doctors. You know, it just so happens I'm a radiologist and this works for radiology. It also works for ophthalmology and whatnot. But so we're looking for groups that can do this, academic groups in France, for French West Africa, Germany, you know, and it turns out that our second patent actually is specific to allowing us to localize in any language. So we can localize in just a few minutes or a few hours to any language. So, and that includes reports, the user interface, and it's just literally a drop down. So with that, I think I'll stop. I think my time's up, so, or close, I'm not sure. I think that's it. Thank you.